Okay, so let me draw this so that you can see. Y or X? Alberto, you tell me, Y or X? Okay, this is the, can you see? Yeah. This is the vertical line. What is the equation for this vertical line? If this is 1, this is 2, this is 3, that's x equal to 2. So you tell me, X or Y? We don't, you're just kidding? Okay, how about for this y-axis? So what is the equation for y-axis? For y-axis is this vertical line. What is the equation, Alberto? It's x equal to 0. The logarithm always passes this point. Like that. But getting closer and closer to the y-axis. So the vertical asymptote is this y-axis. So we say, what is the vertical asymptote? Is x equal to 0. This is a line. Okay? So y or x? It's x equal to 0. Because all the points here, the x values are the same. They are all 0. But how about y? Y could be any number. Okay? So y or x? X equal to 0. Okay? All right. Thank you. Now, let's look at those problems, okay? I'm going to go over each one so that you all review. Now, let's look at 7b. Log to the base 7, okay? And I want you to keep this base small, okay? Now, you have square root 3a plus b in the numerator, and then the denominator is x cubed times y. So my friend, tell me, this is what? Log of a quotient. Is that right? Okay. All right. So log of a quotient, you can use the quotient rule. It will become difference of logs, right? Now, I want you to tell me if this is correct. One of the students do this. Okay? All right. Is this correct? What's wrong? Come and point to it. Here? Okay. What else? Well, actually, this student realized this is a log of a quotient, so it will be a difference. But then he saw this is a product. So he tried to expand it and say it's a log of a sum. So he just do this. Where's wrong? Tell me. Here, it should be minus. Okay? But why? Oh. Okay. Why? It's because you are subtracting the whole thing, so you should have a parenthesis here. So to avoid this kind of mistake, okay, we try to write it as following. And I explained that earlier in my office. We will try to write it as a product. So this times x to the power negative 3 times y to the power negative 1. Are you with me? Yeah? Because then if you have a product, you only need to write it as a sum, right? So this is a single log, right? Single log of a product become what? Become sum of several logs. Okay. Is that okay? All right. So now, at least you get it right, okay? Here, you get it wrong. You get it wrong. Right and wrong is different, okay? Right? You get it wrong, and no matter how much you do after this, you don't get a score. Now, at least you get this right. Next, you will try to use the power rule to get the power to the from as coefficient. Is that okay? All right, so now you have what? Log to the base 7, and then this is 3a plus b to the power what? 1/2, right? So now you know this 1/2, the power could be taken to the front as coefficient. This is a power, so you can take to the front. This is a power, you can take to the front. So it becomes minus 3 log to the base 7x minus log 7y. Is that okay? And this, if you take it to the front, it will become this. All right? So how to avoid this kind of mistake? This is one way. Try to write it as a product. Log of a product becomes sum of logs. If you say, oh, Dr. Chen, I'm very good in division, so I don't worry about that, then that is okay. Okay? Then just be careful when you write it. When you write as a difference, you want to write it this way. So let me tell you. It's log to the base 7, and then 3a plus b to the power 1/2 minus log to the base 7 x cubed y. Okay? Now you have to know that when you try to write this as a sum of log, you are doing this big brackets. Okay? Log to the 7 x cubed plus log to the 7 y. So later, when you distribute this negative sign, you will have subtraction here. Is that okay? All right?
And then once we distribute the negative,
And then you will, yeah, of course.
and we're done?
Yeah, of course. This is the same. It's the same as this. It's the same as this. Okay. All right. You box your answer. This is your final answer. Okay? All right, next, we are going to do natural log of 28 a squared b over 12. Is that 12? C to the power 5 m. The same as the previous one. This is a log of a quotient, right? Log of a quotient. So if you want to not to deal with the subtraction, you just write this as a product. Before you do anything, you can simplify 28 over 12. Can you? They have common factor what? 4. So you can divide by 4, divide by 4. So you get this. Is that okay? So you get what? 7a squared b times 3 to the power negative 1. Tell me what is next. C to the power negative 5 times m to the power what? Negative 1. So now become a log of a product, right? So by the product rule, it will be what? Log, natural log 7 plus natural log a squared plus natural log b and so forth, right? Plus natural log a squared plus natural log b plus natural log 3 to the power negative 1 plus natural log c to the power negative 5 plus natural log m to the power negative 1. Yeah?
So I have a question. So then why wouldn't it be, for the one on the top, why wouldn't it be half log 7 times 3, and then the same thing, half log 7 times a, and then so on and so on? You know the one on the top, the one we just did, the example, the one you boxed? Right there? You know how it says half log 7, and then it has the a parentheses 3a plus b? Wouldn't you multiply that too?
You mean take this 2 to the front?
No.
We are using the product rule right now.
Yeah, that's why I'm asking for the one on the top.
Oh, for this
So,
one.
Since we have since we have 3a plus b like in parentheses, wouldn't we multiply that out by the half log to the base of 7?
Oh, so you have like half log to the base 7 of 3a and then plus?
Yeah.
No, it's wrong. We only have product rule. We don't have, no, there's no such things about, well, thank you. I have to give you extra point. This is a, yes. Because this is a common mistake that I didn't mention. People tend to write this to be is 1/2 log to the base 7, 3a plus b equals to 1/2 log to the base 7, 3a plus 1/2 log to the base 7b, right? Is that what you're trying to do?
Yeah, but yeah, I guess.
No. There's no such, you only could have a product become sum, but then the sum, you go nowhere. No. That's why, remember, I want you to write log over what? A product. You can only rewrite it if it is a product or a quotient. If it's a sum or difference. No, stop there. You have to stop there. You cannot do this. No way. This is wrong. Is that clear? Yeah. Thank you. Yeah, no way. Okay, this is a sum, right? 3a plus b, log of a sum. No, you cannot do this. Okay? But log of a product, like what we did there, then it will become sum of logs. Okay? Is that okay? This is by the product rule. Okay? And from here to here is using the power rule. Okay? If you do this, it's called sum rule. No, there's no such sum rule. No. You only have product rule or quotient rule. Or you have power rule, right? Okay? But I try to make you just use the product rule because a lot of students are not very good in subtraction. Okay? All right. Now, let's continue here. We use the product rule to make a log of a product become sum of several logs. Now, what can we do next? What can we do next? Say it again?
Change the negative exponents to the subtraction.
Yeah. So that is make use of what rule? Power rule, right? All the powers can go into the front as coefficient. Is that okay? So what do you have now? So by using the power rule, okay, by using the power rule, it becomes natural log 7 plus 2 natural log a plus natural log b minus natural log 3 minus 5 natural log 5 minus natural log m. And here you go. This is your final answer. Is that okay? Okay, so. Yeah, sure. So obvious. This is C. Thank you. Okay? Any more? All right. So far, so good? So I think the rest are similar. Okay. Well, actually, 6b is a good one to do. I will do that one. Is that okay now? Can we continue? Okay. 6b is natural log to the base 5 of x squared minus 3x minus 4, and then minus natural log to the base 5 of what? X minus 2, right? and then minus log to the base 5 of what? X plus 1. Okay. I want to remind all of you. Go back to what we have done here. You make all these log as what? A sum, right? There are so many add up together. So you can bring, okay, one more time. The problem we have done previously, I could ask you backwards. In other words, I can say, now, students, please write this expression as a single log. So what do? Oh, you want to write this expression as a single log? Then first, I try to make all of the terms have coefficient 1. Well, this coefficient is 2, so I what? I move back to the exponent. Do you see that? This coefficient is -1. I move back to the exponent. This coefficient is -5, so I use the power rule, move it back to the exponent. Do you see what I'm saying? And then, this is a sum of many logs. I can use product rule and say it will become a single log of a product. So just multiply all of those. So that is the product rule. And then you write this as a fraction. The same way for this problem. This has how many logs? 3 logs. Okay, so what is the coefficient here? 1. So you're fine. What is the coefficient there? So you would like to bring the -1 to the power. Okay, so you say log 5 x squared minus 3x minus 4 plus log to the base 5 x minus 2 to the power -1. What is the coefficient here? -1. So I'm going to write this plus log to the base 5 x plus 1 to the power -1. I bring the coefficient back to the exponent. Is that okay? Now, I can use the product rule now, right? Because this is several logs add together. It will become a single log of the product. Is that right? Okay? So what is that? X squared minus 3x minus 4 times x minus 2 to the power -1 times x plus 1 to the power -1. Is that okay? Yeah? Yes or no? Yes. All right. But when you have negative exponent, you take the reciprocal, right? Okay, so you will have x squared minus 3x minus 4 over x minus 2, and then here, go to the denominator like this. Is that okay? Okay. Can I simplify this? Yes. How? You can factor the numerator. How do you factor the numerator? X minus 4 times x plus 1. Yeah? These two are common factor. So I can divide x plus 1 from the numerator and denominator. So now the answer will become log to the base 5 x minus 4 over x minus 2. Is that okay? Does it make sense now? So one more time. When you want to have several logs add or subtract together and make it as a single log, first of all, you try to make their coefficient to be 1, right? Now their coefficient to be 1. Using the power rule, bring the coefficient back to the exponent. This is what we call the power rule, right? And then, using the product rule, make it as a single log, right? They will be all multiplied together. And then the rest, just simplify. All this, just simplify. Simplify that. That's it. Is that okay? Good. And I think this is the same. How about this? Okay. Find the inverse. Okay. F of x is natural log to the base 3 of x plus 4 minus 5. Okay? Tell me, is this function one-to-one? Yes, because what? Because it passes the horizontal line test because it is increasing, right? You just need to shift to the left 4 units and shift down 5 units from the fundamental function, right? So it is one-to-one. So if it is one-to-one, its inverse exists, right?
Yes.
Yes? Okay. How do you find that?
Make it equal to
F is one-to-one because it is increasing and passes the horizontal line test.
But it's going down 5, isn't it?
Yeah, its graph is the same or has the same shape as y equal to log to the base 3x. By shifting it to the left 4 units and down 5 units. Okay? It was like this. Here is 1, 0. You just shift to the left 4 units, okay? And then shift down. So the shape is still the same. Part B. Find its inverse. What do you do first? You will let y equals to the function, right? And then interchange x and y. So it become what? X equal to log to the base 3, y plus 4 minus 5. How about step 3? Solve for y. Great job. How do you solve for y? You add both sides by 5. You get x plus 5 equals to log to the base 3, y plus 4. Well, I haven't got my y. Okay, how do you get your y? I want you to do yourself, okay, on your notes. Yeah. Awesome. This is the base. It should be 3 to that. Yes. Yeah, 3 is the base. What is the base? No, it's increasing because it's the same shape as this. Because increasing is because the base is greater than 1, right? The base is greater than 1, so it's increasing. Yeah. All right. It's 1/2, so the base is 1/2, it will be decreasing. Yeah. It's still 1-to-1. Increasing or decreasing? Those up and down, like a roller coaster kind of things, you know? Like sine, yeah, like a x squared, right? Go down and up. Those are not passing the horizontal line test. Okay, so now what do we do? How do you get y plus 4? Well, you will what? Write this in the exponential form. What would be that? What is the base, my friend?
3.
The base is 3. So you say y plus 4 is 3 to the power x plus 5. Is that right? You write this as exponential form. So now what is y? So y is 3 to the power x plus 5 minus 4. Ah, you got it. So step 4, you conclude. So f inverse of x is 3 to the power x plus 5 and then minus 4. Okay? Is that okay? Remember what we say, when you do inverse, actually you are reverse the order and then you take the inverse operator. So let's see. What did you do originally? You plus 4. Okay, so let's see what is the action, and then you will get a feeling. All right. Start with x. What do? You plus 4, and then, okay, one more time. I need everybody's attention. Okay. The original function f, you get an input x, and then what do? You plus 4. And then you take the log with the base 3. And then you minus 5, right? So let's predict what will be the inverse. You go reverse, reverse, reverse order with the inverse operator. So to reverse it, you have to first what? You add 5, right? This is what you do the last. So you will do first, but then subtraction will become addition. So you get something, you will add 5 first. What is the inverse of log with base 3? You will be exponential with base 3, right? So you add 5, and then take the exponential. See that? You add 5, and then you take exponential with the base 3. And then what is the last one? You subtract 4, because that was the first action. You see what I'm saying? The inverse function is found by reverse the order of all those inverse operators. Okay? All right. But this is how you show people how you find it. All right. I think we're done. And with such a thorough, yes? For C, yeah. And I can tell you, my friend, I am going to, that is involving with stretching. So in the exam, I will give you a simpler one. Okay? But let's do this. How do you graph this function? Well, first of all, these are the shifting or stretching related to x, right? Is that right? Okay. So let's look at this plus 6, okay? If you get the plus 6 here, if you have what I want to tell you is, when you do this kind of transformation, you always try to also reverse the order and use the inverse operator. So y equals to natural log x. Sorry?
Is that going up? Moving it up?
No, left. Moving to the 6 to the left.
Let me give you some scenario, and then we will look at this hard one. Okay. So if I know this, if this is given, and you know this is given, right? You know this. Okay? How to find y equals to x plus 6? You tell me. Well, the x is going to plus 6. So the new x, this is my new x, right? New x value needs to be 6 less to get the same y value, right? So when you say the x value needs to be 6 less, when you say 6 less, okay, x is horizontal direction. So 6 less means move to where? Shift to where? To the left. So to find this, we just shift the original graph to the left 6 units. Is that okay? So if you know this, and you know that is this shape, right? This is 1, 0. Okay, natural log. You shift to the left 6 units. -5. So it's going to become, so the vertical asymptote is going to be here. When you shift to here, it's going to be like this. This is y equal to natural log x plus 6. Is that okay? So far, so good? Yes?
So in the test, we're going to have 3x plus 6 or just
Okay. When I ask you, I will on the test, I will not give you this coefficient. I will make it simpler, okay? But I'm going to teach you. You need to learn. So what is this 3 does for you? It's also horizontally. So now you get this. Your x is going to be changed to 3x. All right. So what does it mean? It means, oh, my x is going to multiply by 3. So means what? My new x only need to be 1/3. My x value only need to be 1/3 means what? You compress. Okay? You compress it. The x value only need to be 1/3. So this is -6. Compress 1/3. -5 will be -5/3. -6 will be -2. So it will be here. Okay? And -5/3 is there. This. So this one is y equal to natural log 3x plus 6. Okay, because, all right, so let me put here. I make another scenario, okay? If we know the graph of a function, this is a general function, okay? How to graph 3x, f of 3x. Okay, see, originally it was x. Now the only change is the x replaced by 3x. What happened? What has been done? Oh, x will multiply by 3. So if I want to get the same y value, my new x, this is my new x, right? This is my new x value. Needs to be what? Needs to be 1/3 of the original. Okay? Is that okay? I know this is the compression is not the emphasis, but we learn it. So if you get that, then you will know the -6, the vertical asymptote is going to become, what is the 1/3 of -6? -2. It will move to here. What is the 1/3 of -5? It's -5/3. It's here, somewhere near -2. Okay? So you compress. I will not test you this, but you know about this. Okay? On the exam, you will be asked something like this. X plus 6. The coefficient of x will be just 1. So you don't have compression, just a shifting. Yes?
How did you get the 1/3?
How do I get the 1/3? Okay. It's coming from this. Let me show you this. For example, you know the graph of absolute value, don't you? Everybody know, right? What is the graph for absolute value? It's a V shape, right? So it means what? 1 is 1, right? 2 is 2, right? And 3 is what? Is 3. Negative 1 is 1, negative 2 is 2, and negative 3 is 3. Is that okay? All right. Now, I want you to graph y equal to absolute value 3x. How do you graph it? Then you say, oh, Dr. Chen, the only difference is it was absolute value of x. The only change is I'm replacing x by 3x, right? Just like what I said. The only change for, this is a general expression. I only change x by 3x. So what is the change? So listen. When x equal to 1, you get 1, right? When will you get 1 here? In order for you to get y equal to 1, my x only need 1/3. 3 times 1/3 is 1, right? Because you multiply by 3. So now somebody is going to triple me. So my value only need to be 1/3. So 1/3, my y value will be 1. Is that okay? All right? So here, 1/3, my y value will be 1. And then when I am 2/3, my value will be 2. Okay? This is 2/3. And when I am 1, my value will be 3. Are you with me? So means what? Means I am I try to compress the I'm compress the whole graph. I compress the whole graph by a factor of 3. Okay? You know what I'm saying? I compress. This is a compression. I compress the whole graph by a factor of 3. If you have a 3 with the x, that's a compression. So if I have 1/3, it's what? It's a stretching. Okay? This is something about the transformation. However, I will focus on shifting because shifting is easier for you. Okay? So let's back to this one. If I have natural log of x, you know it's this one, right? What is y equals to natural log of x plus 6. You will say what? Only shift to where? Shift to the left by 6 units. Is that okay? So how about this? How about if I want to graph y equal to natural log x plus 6? Oh, this plus 6 is outside, right? Then what do you do? What do you do? You shift what? Up 6 units. Is that okay? Compare these two, okay? They are different, right? This one, you shift the fundamental function to the left 6 units, right? And this one, you shift the fundamental function what? Up 6 units. Because this happens in the y direction, right? But this happens having the impact about x. So this is a horizontal level right. Is that okay? Yeah. You need to compare this. If you can compare this, you are awesome. Okay? The stretching is what you learn, but I'm not going to test you. Do I make it very clear? Yes. The domain. Thank you. What is the domain? Awesome. All right. So find the domain. So let me put this as A, and that is B. Okay? For A, what is the domain? Well, for logarithm, this has to be what? Greater than 0. So the domain, let me rewrite the problem, okay? F of x is natural log x plus 6. So what is the domain of f? It will be all the value of x such that x plus 6 has to be greater than 0. That's it. And x is a real number. Okay? And what is that? That means x has to be greater than -6, right? Okay? So you can draw a graph on the side. Has to be greater than -6. Say this is -6, so it will be an open interval. Is that okay? So the interval notation will be this. All right? How about range? How about range? Remember, I just shifted to the left 6 unit, right? What is the range? It's still all real number, right? It's still all real number. Are you all with me? How many of you know, now feel comfortable about the domain and range now? Okay, how many of you still not quite sure what is the domain and range? Okay, thank you. So for this part, do you understand? Because the log, look at the graph of log. It's all past this point, right? The domain has to be what? See, there's no graph here, right? So the domain is what? Positive number. Is that okay? This is what? Natural log x, right? Is that okay? But now, if I'm going to talk about this, I have to shift to the left by 6 units. Okay, so this is -5. And this is my asymptote, okay? So y equals to natural log x plus 6. The only thing that I need to restrict is x plus 6 has to be positive. This has to be positive. So now it's x plus 6 has to be positive. So it means what? X has to be greater than -6. Yeah. And you see that, yes, it is right, right? All the x value are greater than -6. Yeah.
The only domain I don't get is the ones where you use division, the ones where you combine them. I don't know.
Oh, okay. That is the chapter 5. Yeah. We will do that. How about do range? Okay. So look at this. What is the range for natural log x? It's what? What is the range? Look, this graph is going from -infinity to infinity, right? So what is the range for this graph? All real number. When you shift it, what is the range? It's still what? All real number. Okay? Is that okay?
If it's at -1, if the asymptote's at -1, does that change?
Right now, the asymptote is x equals to -6. Okay? And what do you mean by -1?
The infinity. But what if it was 1 to infinity for the range? How would you pick the range if the vertical asymptote's at -1?
Oh, okay. It's the same because when you say the range, it's looking at the y value. Okay? It's the same. All right? Okay. All right, now let's, so I think this is okay. I don't have time for your quiz today. I will combine that with tomorrow's. Okay? Sorry? Make it take home. Okay, it's a great idea. Okay, okay. Let me tell you what's the purpose of giving you these quizzes? It is for preparing for your midterm, right? Yeah. So I can make today's a take home. Yeah, no problem. I mean, you just need to really understand. I mean, this is very important. Let me tell you why this is so important. Because remember, you learned the log for the previous unit, right? Now you continue. Don't you feel like you're getting better and better understanding about log, right? Domain and range. You are going to continuously learning those. Okay. All right. Let's look. You're so interesting. However, you have to be honest with yourself, whether you know or not knowing. Okay, so tomorrow, we are going to have the second part, the rational, in class. Okay?
Can you explain that a little bit more?
Yes, we are going to do that. Yeah.
Would you please tell us how the midterm would be? It's going to be divided in 3 days, you said, or 5 days?
What are you saying? Say it again.
The midterm
It's going to be divided into portions so that you have focus. Yeah. I mean, because there has word problem part as well. Yeah. I'm going to help you guys. Yeah. The unit 1, some of you actually mentioned that you would like to, make it better and talk to me. I will try to see, okay? The midterm is the chance for you to really, take care, your grades being bumped up if you do a good job of it, okay? There will be a little part for think of your unit 1. Did you finish your, yes? Yeah, sure. You're so interesting. You are very interesting. But I can feel you are eager to learn, right? Okay. You know what? I'm not afraid to let you know what type of problem, because this type of problem, we have done it for 2 weeks, right? We do it almost every day. And what does it mean? It means that as long as you practice, okay, you will get better. All right. Now, what is 5.2? Oh, you know what? Yes. Yes. Can I have you pass your quiz so that Renee can record it? Yes. Okay. You have to pass all of the same row. Okay. Don't mix them. Don't mix them. Okay, I'm going to reinforce one rule about the cell phone. Okay, if you are using your cell phone in the classroom, means you agree to bring the treats for the whole class the next time. Okay, we all agree that, or you will have 5 points deducted. Yeah. Or you are going to have points deducted from the next exam. Okay? I really want you to engage.
Wait, but what if you want to take a picture of the screen?
You may. You can take pictures, no problem. Yeah. Can you just use this, because the other tutor take it home too. Yeah. Okay. No, you have to give them points from 0 to 10. Okay, now I need all your attention. This is not hard if yesterday's lesson you understand. Okay, what we're
Post up the thing on
on Canvas,
if you post up the first one.
the PowerPoint. Yeah, the PowerPoint is on. Yeah, the PowerPoint is already on Canvas. All right, let me tell you. Okay, hold on. pay attention to the PowerPoint if you want to draw down some light. Otherwise, I will upload it so that you all have it. Okay? Okay. Now, what we learned yesterday was multiplying and dividing. Today we are learning what? Addition and subtraction. It will be easy if they have the same denominator. Okay? Well, if they have the same denominator, what do? You just add up the numerator. Am I correct? So 3c plus 4c is 7c. Easy, right? How about this one? Do they have the same denominator? Yes. What do? You just having the same denominator and you subtract the numerator, right? Awesome. Okay. Now, if you don't have the same denominator, this is when you have the same denominator. If you don't have the same denominator, what would you do? You have to find what? Least common denominator, right? Okay. So like for this problem, do they have the same denominator? No. So what do? You factor first. Try to factor them. The first expression, you can factor it as what? 2 times 3 minus w, right? How about the second one? 3 times 3 minus w. So what is LCD?
3 minus w.
What is LCD?
3 minus w.
No. What is LCD? 6. Yes, 2 times 3 minus w. Okay? Oh. Is that okay? Come on. Okay. All right. Now, you know how to find the LCD. Now, let's do this. Find this LCD. Sorry? No, I did not. Because this is just to tell you how you find LCD. But you learned that in your, Do you want to, well, we just need to read through it. But it's better that you go through the example and find out. How do you find factor first, right? What is the first step? Factor every denominator completely. And you write it in what? Exponential form. What is the second step? You will list down all the common factors, okay? If the factors are common except for their powers, then you use what? The highest power. So we're going to see. Okay, how do you find the LCD? You factor 16. What is 16? 2 to the power 4. What is 56? It's 7 times 8, right? So you factor them. 2 to the power 4 times x squared times y cubed. How about here? 2 cubed times 7 times x times y to the power 4. Is this hard for you guys? No, right? All right, now what is LCD? You tell me. What is LCD? It will be 2 to the 4th times x squared times y cubed, y to the 4th. We have to. Okay, no. This is good. This is good. All right. One more time. You tell us. What is LCD? It's 2 to the power 4 because you are choosing the highest exponent, right? And then times what? 7. Thank you. You need the 7, right? Because otherwise, it's not common multiple. Okay, you need 7. Okay, 7 to the power what? 1. You don't have 7. So it's 7 to the power 0, right? You don't have 7, but you do have 7 here. You are finding the multiple, you see? Okay, and then next is what? X to the power what? 2. You get multiple. And then times what? Y to the power 4. Is that okay? This will be their LCD. Yes or no? Okay? Okay. Do you know why? It's like this. Okay, for this two, what is the LC? What is the least common multiple? We are going to find a multiple, right? So you need to include, if you say I have a z here, Okay, what is the LCD? It will be x squared y to the 5th. Do I need to have z? Yes. Why? Because if you don't have z, if I don't have z, then this is not a multiple of that. You need to be a common multiple of both. So you need to include all the factors. Is that okay? As long as you have that factor, you need to include it so that it is a factor. It is a multiple, common multiple. Is that okay? It's just like this. Okay, let me use number. Maybe it's better that you have a number. 3 times 5. That is 15. Okay? How about 20? It's 4 times 5. What is LCM? Least common multiple. It should be what? 3 times 4 and then times 5. Because you need to be a multiple of both. So you need to include all the factors. But then you choose, okay, let me put this to be 100. Okay, this is 2 squared, is 4. You want to choose the highest exponent. Is that okay? Okay, I just changed. Okay? Thank you. Is that okay now? This is, well, you have to know this. Yeah. Because if you don't know this, you cannot do any problems. Okay, so LCD is that. Great job. Now, how do we add this? Okay. How do we add this? You first find the, what is LCD now? XY. So this need to multiply x over x, right? So you will get, do you see that? You multiply x so that you get xy. So you need to multiply x over x. Is that okay? So what will you get? You will get that. How do you add them when they have the same denominator? How do you add them, Victoria? The denominator will be the same. And then the numerator, you just add them. Is that okay? All right. Now, sorry? Is that okay? Question? How about if you don't have the same denominator? Okay? You find the least common denominator, just like what we did. And then you add or subtract. And then at the end, you simplify. Okay? It's better to do one example. Okay. Do they have the same denominator? No. So you try to find the least common denominator. You see, this is 2 times x minus 3. So in order for you to have the same denominator, you need to multiply 2. If you multiply 2 here, you need to multiply 2 there, right? Is that okay? This is something you have done in the previous course, but we are doing that again. Now, the thing is, after you do this, how do you subtract? Okay, so how do you subtract? The denominator now is the same, right? They are common already. So how do you subtract this? 10x plus, right, very good. So 10x plus 12 and then minus parentheses, x minus 2 means what? Minus x plus 2. Did you get that? Yes. Minus x plus 2. Okay? Keep the parentheses. Anyone forget about these parentheses, you will get wrong. Okay? Because you are subtracting the whole thing. So subtract this. So you will subtract x and then plus 2. And then you combine the like terms, you get that. Is that okay? Okay. So this is fairly easy. And then this is the end, the tail for you're so exciting, huh? Shows that you love this section. Okay, So now we know how to, yesterday we learned multiply and divide. This is what? What is line for? Divide. So when you have this long dividing line, you just need to keep in mind, how do you divide? When you divide, you multiply by its reciprocal. That's it. Okay? So let's see. There are different ways. Okay. I'll show you one way here. No, I'm okay. Okay. You know what? It's better that I show you on the side. So, can I, oh, you know what? I will do this. Okay. Okay. Can you see? Okay. Complex rational fractions. So, for example, this is a very complex fractions. What can we do? Remember, I said already, one way you can think is this is a long division, right? So you can consider this is 4 over c divided by 7 over c plus 2 over c squared. Is that okay? Yes or no? It's very straightforward, right? Okay. Can you add these two? Yes or no? No? Yes, this is c squared, this is c. What is the least common denominator? C squared. So what do? You multiply c here and c there, right? Yes or no? Yes. So you say, all right, this is 4 over c divided by 7c plus 2 over c squared. Is that right? Yes. How do you do with this division? You don't say flip it. You say what? You say multiplying its reciprocal. So it will be 4 over c times c squared over 7c plus 2. Yeah? Do they have common factor? Yes, c, right? So you divide out c, you get c. Here you get 1. So now it's 4 over 1 times c over 7c plus 2. Do you know how to do this? 4c over 7c plus 2. Awesome. Awesome. Okay. This is one way. Great job. Okay? People say, Dr. Chen, I also learned in my pre-algebra that if I have numerator and denominator, then I can multiply both numerator and denominator by the same thing. Oops. Okay. So I say yes. Can I? Yes. Now, you look at the LCD. This is the denominator c. C squared. What is LCD? Thank you. You are awesome. So I multiply c squared with both numerator and denominator. So I'm multiplying by 1. Am I correct? So I'm not changing. So now tell me, what is that? 4 over c times c squared, you get 4c. Now, you need to distribute, don't you? So 7 over c times c squared, what do you get? 7c. 2 over c squared times c squared, you get what? 2. Ah, I get it right away. Woo! This is 5.3. Okay, so is this easy? Yes. Which way you like? You like this way or you like that way? You like first one. You know what? We have both sides. Some students love to just use the division. Some students love to find the LCD and multiply with both the numerator and denominator. You are free to use whatever, but you need to know both. Okay? You need to know both. So 5.2 and 5.3 homework will be assigned on Canvas. Is that okay? 5.1, well, yeah, of course. 5.1 to 5.3. And tomorrow you will have a quiz on 5.1 to 5.3 for today. You want the take home? You know what? For me, I think pick up the quiz. Pick up the quiz, okay? Pick up the quiz first. Oh, okay. Thank you. Thank you. No problem.
Are you going to send the quiz right away?
You know what? I think I will make you work on 5.1 to 5.3 today. How is that? And then I will give you the take-home quiz tomorrow all together.
Okay.
Because I need you to study for 5.1 to 5.3. Okay? So today you don't have a take-home quiz. You just work on 5.1 to 5.3. Is that okay?
That's our test for tomorrow?
That's a test for tomorrow.